Okay, I managed to squeeze in another session today, so let's get to it. What I wanted to achieve last time when we finished the previous session was this sort of transformation, a collection of positioned icons into collection of diagrams, but I did some digging and I found this function called position in my backup branch. Let me just quickly show you how it works. So position takes a collection, if I'm not mistaken, of tuples, where the first item is Cartesian coordinates of a graph, and the second item in the tuple is the actual diagram. Sorry, Cartesian coordinates of a diagram is the first item, the second item is the actual diagram. So let's just quickly experiment with this. If we go to render and visual graph, you see that we have a list of tuples, coordinates, v2, and the SVG diagram. Let's run a quick test with what I currently have. Now, in order to use this, we would need the same function, diagram, just applies slightly differently. And let's just make sure I remember how to use this position function. So position function is just a diagram, I think. Let's see. Can't find this function. Is it in the prelude or prelude? I think so. Oh my goodness, this is... let's just go to diagrams. And can't find it here. It's the same package, just two different versions. Okay, anyway, let's try to use it anyway, and let's see what happens. So instead of render SVG, I wonder if we have something like position. We don't seem to have position. Let's see the original version of this function. Which version are we using? Let's see. sure this is what I'm looking for. SVG. Let's try to find the documentation position. Yes. Position. So here we have points. I wish we had access to that source. I need a source code for this. It's the same thing. Let's see here, user manual. I can't find it, but you know what? Maybe we can sort of brute force it. Maybe we don't even have to see SVG options. SVG options is just let's see the latest version of this package. Okay, beautiful. Okay, so here we have, or should have diagrams. this is going to be it. Okay, perfect. So the latest version is, let's see, 1462. Okay. Let's see, preload. I wonder. Let's see if they have an example of how to do it with SVG backend. That wasn't it. I wonder. Where did I see this? Okay, as I said, let's try to brute force it, and let's rely on the compiler to tell us what type would be required. So render SVG, what is it going to return? Let's do diagrams, prelude, position, and let's go back to my example, and position should accept collection of tuples. Visual graph. For now, let's not worry about the correctness. Let's do ABC in the same type. Just let's change this type. SVG B. Okay. That in our case. In our case, this is going to return an empty array. Sorry, empty list. So So this is ABC. ABC. Let's see what happens. No. Okay, match type. The expected, and this is in line 189. The expected was just double NIO. Let's see my example. Have main width. That just doesn't work. The types are just very incompatible. It looks like what is expected is in this position is a list of tuples, coordinate and IO, and here we have coordinate and diagram. I'll probably have to do some digging before the next session, but what I will have to figure out is how to do render SVG in the same way as position, where you're supposed to specify the coordinates. Okay, so what do we have here? Specified output file using the requested size. Enter a diagram as an SVG, writing to the specified output file and choosing specific backend options. The ID prefix derived from the no. Hold on. Render SVG returns IO. Maybe this is a problem. I doubt it, but yeah. Okay, so that's the homework for me for the next session. how to take line 188 to work like the line 189. To have the combinations of diagrams and their Cartesian or coordinates. Maybe let's spend 5 more minutes today trying to do some research. Let's start from the beginning. It's a Euclidean space. Two-dimensional Euclidean vector space. Okay, I should probably stop using the term Cartesian space. Yeah, this is it. The position function takes a list of diagrams associated with positions and combines them while placing them at the indicated absolute positions. At points is like position, takes a separate list of points, a list of diagrams. Let's see. Nope, it's not even a thing here. I'd love to see where this position function is. Let's try to go to GitHub with this. Okay. Sure, nothing. Points. No. Let's try to check the types some other way, like def. No. Okay, expected is a string. Does it mean that if I have this, type, should compile? It does compile, okay. So it means that I can potentially position my diagrams and then still use the render SVG and with DF. Would that work? Yes, it does work. Okay, perfect. So equipped with this knowledge, I can start planning for the next session where we will try to combine a list of tuples of origin, the coordinates or absolute positions with diagrams into a single diagram of this type, consistent with the second part of the tuple, and then render that. Okay, this is good. This is good. Let's just leave some comments. Oh, you know what? This is just temporary. Positioned icons we don't have to worry about. This comment is not relevant. Oh. Okay, I think we're good. Took a little bit of time, but I'm happy that we have a clear plan for going forward. Commit. Okay, thank you very much, and thank you for your patience and your attention, and see you again next time.